Every row in Postgres carries a transaction ID stamped at birth. Those IDs are just 32-bit integers, and when they wrap around, Postgres has to stop accepting writes. Here is exactly how that happens and how to stop it. Postgres assigns every transaction a 32-bit transaction ID. Tuples store those IDs to decide what each reader can see. Because the counter wraps around after about 4 billion, rows from the distant past can look like they are from the future unless Postgres intervenes. Look at the tuple headers. The old version of the first row has Xmax set to transaction 415, marking it dead. The new version born at 415 has Xmax of 0, so it is live. Every reader compares its own transaction ID against these fields to decide what it can see. XID arithmetic is modular. Once roughly 2 billion new transactions have run, the row born at XID2 sits more than 2 billion steps behind the current counter, and Postgres interprets it as belonging to the future. The row vanishes, freezing replaces that raw XID with a sentinel that means visible forever. The system catalog column relfrozenxid records the oldest unfrozen transaction ID in a table. Calling age on it gives you a transaction count. When that count approaches autovacuum freeze max age, autovacuum kicks in with an aggressive anti-wraparound pass to freeze old tuples. In a pull request, flag any change that disables autovacuum or raises freeze max age far above the default. Without autovacuum running anti-wraparound passes, the XID counter eventually closes in on unfrozen rows, and Postgres will refuse all writes to protect data integrity. 3 things to take away. XIDs wrap around after 4 billion, so freezing is not optional. Never disable autovacuum or inflate freeze max age on production tables. And always monitor relfrozenxid's wrapper table so autovacuum has a safe window to do its work before Postgres is forced to stop writes entirely.